Hi everybody, myself is Shashikant Khilare. In this video I am going to explain the concept of conditional probability. Suppose we have two events A and B, and these two events are dependent on the sample space omega. If event B is known, in that case we can easily find out the probability of event A, or suppose event A is known, in that case we can find the probability of event B. Now first we see the conditional probability of A given B. Suppose A and B are the two events dependent on the sample space omega, then the conditional probability of A given B is denoted by probability of A given B. It is defined as probability of A given B is equal to probability of A intersection B upon probability of B. Here probability of B is greater than 0. Similarly, we can define conditional probability of B given A as probability of B given A is equal to probability of A intersection B upon probability of A. Here probability of A is greater than 0. Now see one example on this. A pair of pair dice is rolled. If sum of it has appeared, find the probability that one of the dice shows 3. If two dice are rolled, then sample space contains 36 outcomes. On this sample space, the event B is defined, and which is equal to sum of two numbers is equal to 8. Then event B contains the outcomes 2, 6, 6, 2, 4, 4, 5, 3, 3, 5. And we have to find out the probability that one of the dice shows number 3. Let A is equal to one of the dice shows number 3. Then find the A intersection B. A intersection B contains the outcomes 3, 5 and 5, 3. Now find the probabilities of event B and probability of A intersection B. Probability of B is equal to 5 by 36 and probability of A intersection B is equal to 2 by 36. And required probability is probability of A given B, which is equal to probability of A intersection B upon probability of B. That is, required probability is 2 by 5. Now we see the concept of multiplication theorem. In multiplication theorem, or by using multiplication theorem, we can find the probability of simultaneous occurrence of the events in case of two events or three events or more than three events. The statement of multiplication theorem is, let A and B be the two events on the sample space omega, then probability of A intersection B is equal to probability of A given B into probability of B, or probability of B given A into probability of A. Second statement is, let A, B, C be the three events on sample space omega, then probability of A intersection B intersection C is equal to probability of A into probability of B given A into probability of C given A intersection B. Now see one example on this multiplication theorem. A lot contains 12 items, of which 4 are defective. 2 items are drawn at random from the lot, one after other without replacement. Find the probability that both items are non-defective. Now first we define two events. Event A is equal to what? First item drawn at first draw is non-defective, and event B is equal to second item drawn at second draw is non-defective. Then probability of event A is equal to, which is equal to what? In lot there are 8 non-defective items, and we have to find out only one non-defective atom. This can be done in 8 ways, and in lot contains total 12 atoms, out of which one atom can be drawn in 12C1 ways, which is equal to 12 ways. The required probability of event is equal to 8 upon 12. And now to find the probability of event B, in the first draw we have drawn a one atom from the lot. Now lot remains 11 atoms. Now to find the probability of event B, that is conditional probability of B given A, which is equal to 7 by 11. In lot there are 11 atoms and there are 7 non-defective atoms. In the first draw, one non-defective atom is drawn, therefore there remains 7 non-defective atoms. Now the probability of both atoms are non-defective is equal to probability of A intersection B, which is equal to probability of A into probability of B given A, and the required probability is equal to 14 upon 33. Now we see the concept of partition of a sample space. Definition of partition of sample space is a collection of mutually exclusive and exhaustive events is called as a partition of sample space. More specifically, suppose we have n events a1, a2, dash 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 an defined on the sample space omega, and these events are said to be form a partition of sample space omega if and only if ai intersection is equal to 5 for all I and j. Here I is not equal to j. That is, if we take intersection of these n events and which is equal to pi, this is the first condition. And second one is what? a1 union a2 union a3 union dash 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 union an is equal to omega. That is, if we take union of all these events and which is equal to omega, if these two conditions are satisfied, then it is called as the partition of the sample space omega.